Rise of AI by DataSoc. I'm Saksham, this is Daniel.
Yeah.
So today we're basically going to be talking about the power of AI, how it's going to improve in the coming years, as well as machine learning, and we'll also get into some basics of Python. So how many of you have done Python before? Okay, so like 70%.
Okay, so people always ask this question, what is AI? What is data science, right? And that's actually a very hard question for us to answer because it actually incorporates multiple aspects, right? I think, in my opinion, AI and data science is like the encompassment of the word STEM, right? Science, technology, engineering, and maths. So you have to be good in all these four sections to be called a real data scientist. And it's extremely hard to find someone who's good at science, technology, engineering, and maths. But because you came to our seminars, you will become probably 50% a real data scientist. So we will hope this will make you happy. Yeah. Oh, so this is a diagram of how do you become a data scientist, right? So as you can see, if you follow the paths of this diagram, you will eventually become a real data scientist. So there's topics like programming, statistics, fundamentals of data science, natural language processing, mining, machine learning, blah, 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 right? And so what we will cover is approximately 5/8 of the diagram maybe. And you will learn all of the red parts in this course. Oh, yeah.
So this is basically what we call the machine learning zoo. These are the different methods used for machine learning. So we've got SVMs, clustering models, decision trees, naive Bayes, and also neural networks.
Okay, so an example of, okay, we kind of know what data science and artificial intelligence kind of is, but how is it used in real life? Is it even useful? So using random forests, deep neural networks, and convolutional neural networks, which we'll all learn this time, this semester, they can find, this is a cancer, they can find which of these cells are cancerous, right? And funnily enough, with AI and data science, the machine can predict even better than a real pathologist whether these areas are really cancerous or not. And they found out that sometimes the doctors, when they say that this is cancerous, it's actually not cancerous. And when it's cancerous, when it's not cancerous, it's cancerous. And the machine shows this relationship between opposite trends and stuff. And also, if you add, for example, if you add a pathologist and artificial intelligence, you can see that the error rate has been reduced dramatically from 3.5% to just 0.5%. Although this error may seem small, a 2% difference is probably life or death.
So here you can see the models of various types of neural networks. So we've got long short-term memory, recurrent neural networks, and generative adversarial neural networks. So all of these have their own applications. The thing with neural networks is that they're a new form of machine learning, and they're much more effective than older models, such as linear regressions and such. Its main purpose is for analyzing complex tasks. So when you have, say, facial recognition or self-driving cars, or in the military, if you've got a weapon system, if you analyze a target, you have to decide to shoot or not to shoot. All these complex decision-making processes where life and death are involved, neural networks perform very well in these areas.
Also, the examples you see, so this is chemistry. So if you're a chemical engineer in something, you want to discover new chemicals or new molecules which are strong, durable and stuff. And in fact, you can use generative adversarial networks and other evolutionary networks to kind of let the computer mine itself, discover the entire parameter space to find the best element. So you don't need to check every single element. The computer will do that for you. Right? And this is a car chassis model made by a machine learning algorithm as well. And what the researchers realized was that using machine learning and data science, they made a model which kind of looks like a skeleton of some animals. And so using these models, you can mine the entire like space of everything, and you can find the best optimal one. And this is what we will learn this semester. Oh, okay. So there's more different types of networks. As you can see, there's like tons and tons of different models and stuff, and it's extremely hard to know every single one. We will try like teaching you some of them, but not all of them this time. So as you can see, this is an artwork so pretend you have artwork 1 and artwork 2, and using convolutional neural networks and other models, what they can do is they can render this photo and this, right, into something like this. So you add like, this is like art. You can add 2 different types of photos and it can render it into like a different style. And in the olden times, well, not really olden, I don't know. Yeah, in the olden times, they can't do this, right? How can you render another image with another style? Also, this is Google's Deep Dream, and using, as you can see, this is convolutional neural networks as well. In Google Deep Dream, you can see that there are some strange patterns inside the photo. The researchers don't, like, this is the aspect of machine learning. The model is very strange, and then each different spot can have different representations, and the model highlights this with these strange, like, you know, there's a dog face over here, and there's some other strange faces. This is what, like, the model's brain kind of looks like. So this is what the model kind of sees. And for music, if you're a musician, you can make music as well. So as you can see, machine learning, data science is applied literally everywhere.
So one more thing, as you can see, the implications machine learning has, it's not just repetitive tasks which are being automated. Machine learning is getting much better at creativity as well. For example, creating music. It's predicted by 2050 AI will be able to write a best-selling novel using deep learning techniques.
So yeah, as Saksham said, machine learning, data science, and artificial intelligence is getting to becoming more creative. And so you always hear people like saying, how can computers become creative, right? Well then don't forget, who wrote the computer algorithms? The humans, right? So it's actually you that are the creative people. It's not the computer, it's you, right? But the computer is starting to become creative, right? It's starting to develop some form of like automatic trend analysis, and it tries to find the best optimal solution. And so pretend if you want to like make a good music, right? Then it will try to find the best tune. So over here you can see this is translation, right? So if you apply the same concepts, how does it optimize for the best translation, right? So the machine will automatically find the best like combinations and algorithms to like translate languages. And I think Facebook, they had like I think it was a few, I don't know, it was 1 month, I don't know, recently they had 2 bots talking with each other, and they talked in some very random language which we didn't know what it was. So see, humans don't even understand what the language they're talking about, right? So how can computers not be creative? Because we don't even know what the computers are like talking about. So this is speech recognition, and as you can see, using deep learning, the error rate has dropped a lot, right? From okay, this kind of skewed, but I think it kind of dropped maybe by 5-ish%. And 5% is a lot for error rate. If you drop by 0.1%, that's a lot. But if you drop by 5%, that's fantastic.
So now we'll discuss the future of AI.
Okay, yeah. So probably you know this guy, Elon Musk, right? He was one of the co-founders of OpenAI. They wanted to, so as you know, AI is extremely powerful, but at the same time, if it goes into the wrong hands, it will cause like, you know, havoc. So I think Elon Musk said a few times ago that, you know those self-driving cars? One of the biggest problems that he has to fix is what happens if someone hacks into the system, right? Then would that mean that all the cars go like haywire? Would that mean all the cars like come to a stop? So what happens if the whole world uses self-driving cars? What will happen to the world? So he needs to, so the engineers at OpenAI, the engineers in his company Tesla, right, in company work like OpenAI, Google, and other companies, they want to find a solution to this problem. So if we teach you some of these concepts, I hope you'll be able to solve these problems in the future. So this is Google's DeepMind, the AlphaGo, right? They won a game against the grandmasters of Go. So maybe people like, so if you realize that a computer can play chess, right? So if you do the highest difficulty 10 or something, the computer will check every single option, right? And it's extremely slow if you have a very slow computer. But what Google DeepMind did was they did a different approach. They didn't check every single solution, because if you check every single solution, like if you put a black or a white piece like one place or another, you have to check. The amount of iterations of checking is more, I think they said it was more than the number of atoms in the whole universe. How can you check every single one, right? But then another question is, how did they make an algorithm which can beat the grandmasters? So what they did was they used two different types of networks. One is a policy network, which I think uses tree modeling and Monte Carlo simulation methods. We won't be learning this because it's way too complicated, but you'll somehow get an intuition. So using some tree search methods, they can find the best spots to put. Right, and the funny thing is, they don't need to go through every iteration. It takes like, I think Google takes like 0.1 second to get the result. And so the second one they train is called a value network. So before, what they couldn't do in the olden times, like if it was like a chessboard, they can't check what was the probability of you winning. They can't like give you a number which says, what's the chance of you winning? But now, Google DeepMind, in fact, they can give you a number which says, what is the probability that you will win? And every single time it succeeded. I think if it's lower than 50%, the model just stops, and it tells the user you lose. So yeah, I think they won every single game. I think online they won all 300 games against all the grandmasters. And so, okay.
So as you can see, these are the probabilities of automation in different occupations. So as you can see down here, we've got writers, retail salespeople, accountants and auditors, telemarketers. They are the most likely to be automated in the coming years. But as you can see, there are more trained professions that are also going to be automated. Well, at the moment, it's a low probability, but this will obviously increase as machine learning gets more powerful. So yeah, as you can see, there are engineers up here as well, and also medical professions. There are lots of ethical issues surrounding this as well. For example, would you rather have a robotic surgeon perform surgery on you or a human? I choose a robot, honestly. Because they've simply got, I think they've got a greater accuracy, and if something goes wrong, well, that's unlucky.
Yeah, so as Saksham said, the doctor example thing. So I think the machine learning people, they always argue like, why don't we introduce this into medicine now, right? You don't see it anywhere. I think in China they started to do cancer scanning with machine learning. So the question is why, right? So I think in my opinion, it's probably the lobbyists or the doctors that they don't want this technology in because it will affect them. So that's probably why it's not inside the hospitals and stuff. But anyways, why do we need to put these algorithms in, right? So I can say, for example, so there's a very big problem currently. The algorithms cannot be explained. So you remember you saw the diagram with Google Deep Dream, and there's like a dog within stuff like that. So we can't explain it. And Facebook's language thing, they can't explain the language. So how can we explain, like if we have a medical imaging, how does the algorithm explain why this person has like a disease or something? So that's a problem. So in the future, if you can find an answer to this problem, explain how the model actually works, explain what the numbers inside the model works, and you'll be extremely famous. But if they fix this problem, I assure you that we're going to see more of this in the future, in your life.
Yeah, just on that, so basically the biggest problem with neural networks is that it's a very black box system. So that means it's difficult to determine exactly what's responsible for what function. So if you've got a neural network, for example, basically, so if you have an input going in, so if you have inputs going into this node, and then you've got weights on each of these, and you've got your activation function. So let's say this is responsible for a self-driving car. So this neural network determines that the car should stay within the lane, whether it should apply a brake, whether it should accelerate. So let's say, and also for detecting objects, obviously. So let's say if a person comes in front of the car, and obviously the car should stop, but if it doesn't, say it hits and kills someone, then it's impossible to find out which part is exactly responsible for that. Because if you have standard programming, so like if-else statements, so like if this, do that, then it's very easy to pinpoint the issue that there's a problem in this part of the code. But with neural networks, it's much more difficult because it's very statistical and there are so many combinations of node connections, so it's difficult to pinpoint exactly, say, what was responsible for not detecting the person, or why did the car accelerate when it should have braked. So that's the biggest issue, and if you can solve that, then you'll become very famous.
Yeah, your pops. Like if you actually solve this problem, you'll get like $10 billion. I'm not joking. So one last point about the future of like the world and stuff. So as you know, I think this is, yeah. This is not the. There's another study, I think an Oxford study. They said by 2050, 50% of our jobs will be automated. And it's not a joke because Oxford University did it. Should be correct. But anyways, like if you think about it, think about how the world has changed, right? So when was the iPhone released? Does anyone know? 2008. Okay. How many years is that from now? So 9-ish, 8-ish, 10-ish years, right? So in 10-ish years, look how much the world has changed. In the olden times, if you remember your YouTube videos, 144 pixels or something, hopeless. And then now it's they're doing something like 4,000, wait, what? The very high one. No, it's 1080 is now. There's an even higher one now. Yeah, 4K that. A computer can't even do that. Yeah, but look, 4K, right? Look at this exponential trend of the world. So I assure you in the next 1 year, right, next year, or even this coming months, you will see news, right, talking about artificial intelligence, data science, and data analytics, and they're going to change the world, right? You will see new algorithms, new discoveries, everything new. And I hope you will like our seminars, and I hope you will learn, even if you don't understand these concepts, I hope, because we're going to teach you science, technology, engineering, and maths, so you can get, even if you don't, even if you can't because you don't want to learn AI, you just want to learn something, new, I hope, the programming, the maths, you will understand some of the stuff, and you can apply it to anywhere, right? So if you don't get the AI stuff, just remember your programming, right? Because programming is the most important. Or just remember the maths. We're not going to make stuff hard. We're going to make stuff very easy for you. And yeah.
Not very, very easy.
Yeah, obviously not very, very easy. Right. Sure. Okay, so do people does people have laptops and stuff or computers? Or if you don't have, it's okay. We will show you. So today we'll be learning some Python. So if you have Anaconda, put your hands up if you have Anaconda installed, or Active Python or something. Do you know? Okay, leave your hands up. But now put your hands down. Put your hand. No. Leave your hands up if you have Anaconda or Active Python or something. Okay. Put your hands down if you know how to use it. No, as in do you know how to open it? You installed it, but do you know how to open it?
Any version of Python or?
No.
3.6.
Okay, if you have Anaconda Python, but you don't know how to open it, put your hands up. Okay.
Well, I know if it's Anaconda or not.
Oh, who doesn't have Anaconda Python? Okay.
Oh, wow.
Do you have Kaggle? For the people who don't have Anaconda Python or Active Python, do you have a Kaggle account?
Yes.
Okay. Log into your. Okay, we'll do the Kaggle account first then. Go to your for the Kaggle people, go to your Kaggle account. just log in. So this is only like if you have Anaconda Python, we'll show you how to do it. But if you don't, then it doesn't matter. So if you go to your dashboard for the Kaggle thing, or if you don't want to use Anaconda Python, you can just use Kaggle. It's the same thing. So you go to kernels, right, and then you just click new kernel.
Make sure you create an account first.
Yeah. And then you need to click notebook. And you just type in Titanic or something. Competitions. Just use that one. It'll be like, yeah, so it'll look something like this. Okay, for the people who have Anaconda Python, so for the people who have Anaconda Python, are you using Windows, Mac, Ubuntu, or whatever? Okay, for Windows, you should just see something like Jupyter Notebook, like it's a right, you should see this photo. You should see this icon on your desktop or like in your start menu or something, and just open it up. So open Jupyter Notebooks up if you have Anaconda or on Windows. This is for Windows. If you have Mac or Ubuntu and stuff, you can go to a terminal or like command. Well, this is command prompt, but oh, great. Okay, anyways, go to terminal, right, and just type in Jupyter Notebook, just so exactly. JUP, you know, all of this.
Yeah, just
and
type
then
in
press spacebar notebook and enter. It should work. If it doesn't work, then you probably didn't install it correctly. Is it working? Anyone have issues I can help you? No? Yes? You can put your hand up if you have problems. Or is it okay? So how many people have the, like Python blah loaded up? It should look something like this. Even if you have Anaconda, it should still look like this, right? It has like an in, like a random, like a thing. If you have the Anaconda Python and stuff, to execute code, you just need to, like when you type stuff in, you just press Control Enter. Or I think on Mac, I don't know, it's Mac command.
I think it's command.
Yeah, command enter or something, I think. Yeah?
So you go on kernels and then what do you go? You go.
Oh, you go to kernels, it should be a new kernel. So
Kernels, or just press leave it.
you just press new kernel. See that button?
New kernel and open up the
New kernel notebook.
and just
type in Titanic, competitions Titanic.
It doesn't matter which one you choose, but
Yeah, it's just, yeah.
we're not entering the competition.
Yeah?
You can if you want.
Anyone have issues not opening it up? Or
Mac is still control.
oh, it's still control. I thought Mac didn't have control. Yeah, does it work? Anyone have problems? No, yes? Don't be shy. We can help you. Oh, if you actually, yeah?
Like this.
Wait. Yeah, that's right. Well,
Wait, Saksham, what if I just have 5 minutes?
yeah, that's right. Yeah, that's right.
If I just
Got it right.
It's
Oh, no, oh, yeah. No, sorry.
You have 5
You have to
5 minutes, 6 minutes,
Oh, wait, is
It'll
it?
do for now.
So you do new.
When is it shit? I need to learn that difference. Like, yeah.
Yeah,
Not today.
now they work.
Yeah? Like for visualization.
What's the... Oh, no, that's right. Wait, it should load in. Wait, it should load in to your. Is it open? Is it there? Oh, here. It's here. There. You can copy and paste this into Chrome, and then you just press new. Python. Also, just a reminder, like, so when you go into Jupyter Notebooks, it should be in your web browser. So it will say localhost something 88888 or whatever, and you just have to press new and then Python 3. Anyone else have issues or problems? No? Yes? No? Oh, okay. Just like you can
Okay, so is everyone fine?
I choose to.
Yeah.
You Python first. Yeah. Yeah. Oh, this is window. Oh wait, it should work. Just go to G. Just go to start. Just type in Jupyter. Oh, you just use that. Yeah. Okay. Anyone? Yeah, you can do that. But I would like, does it print out stuff? Yeah. Oh, they do that. Yeah. That's right. Anything? Any other problems or issues? No. Oh. Oh, it's he's very good. This one, Jupyter Notebook. Yes. Any other problems? Oh yeah, if you don't want to use Jupyter Notebook, it's okay. Like PyCharm stuff. Yeah, that's fine. But I would recommend you to use Jupyter Notebooks because it's more streamlined and you can publish it. It also has if you do maths, latex, maths formula stuff and adding like stuff and 3D transform, it's cool. So you should use it. Okay, so yeah, I would just make it bigger. And then it's fine. Okay, so do you wanna? Alright. Okay. So this is we're gonna start teaching you programming now. Okay. And so people will probably ask, why do we start programming and not like maths or statistics, right? Because programming is hard. Okay. Not as like people who have never done programming, it's actually very hard. If you do computer science and you probably did Comp 1511, you probably like if you were like new in programming or 1917, you probably died. It's normal. Okay, so anyways, why are we teaching you Python? There's another machine learning programming language called R, right? Why are we not teaching you R but Python? If you like, wouldn't it be better if we taught you R, right? Because all in UNSW, I think all statistics, all of the courses, actuarial, blah, they all use R. Why not R? Because it's slow. It's chunky, it's slow, and you can't do anything else you want. You can't make a game, right? In Python, you can make a game, you can make websites, you can make whatever you like in Python. So that is why we're teaching you Python, because it's general purpose. R is not general purpose. R is like, one area, just like math statistics. So we'll be learning Python. So your first command, right, is a print function. It should be your first program in your whole life if you do programming like at the beginning. So yeah, you can just print hello world. So all you need to do is you just use the print function, right? And you have to put braces, and you print whatever you like inside. So that you have to put the speech marks. Okay, if you don't put the speech marks, it doesn't work. And if you do, to make this run, either play the play button or Control Enter. Okay, if you press Control Enter, it should work, and you can see hello world. Do you like?
Okay, so now we'll talk about variables.
Yeah. Anyone have issues with hello world? No? Yes? Okay, so delete hello world and just put 2. I'll just say print 2. Just print 2.
We can also print wait.
Oh wait, it should. Huh? No.
You don't need it.
No, I mean, oh, it's the screen.
It's not
Yeah, it's
because
oh,
it's
that
zoomed.
one.
It's
No,
because
it's
it's
the
zoomed in.
projector. No, it's the projector. And it just, great, projector. Okay, so pretend you want to print like, hello, I am 12 or something, right? Something like that. So, okay, so just write, hello, I'm 12.
What?
Just 12, or 1, yeah, that, okay, and top. Okay, that's fine, right? But, okay, so what happens if I ask the user how old you are, right? And I want to print that as a number, right? Hello, I am like something, right? How do we do that? So, we'll be introducing you the input function and variable types, right? So, if you don't like C or some other programming language, you have to classify variables, you have to like define the variable type. In Python, Who cares? Okay? No need to define silly variable types. Way too complicated, wasting your time. So in Python, you don't need to define. All you need to do is use the equal sign, right? X equals to 4, y equals, yeah, you can do whatever. Whatever you put after the equal, it will be defined. So Python automatically assigns a variable type. You don't need to worry about, types and stuff.
Yes, like for example in C you would have to declare x as an integer.
Oh, but you can't do this in Python, okay? It will show an error.
This isn't Python, this is just C.
Oh, yeah, see.
So the good thing about Python is it automatically knows which data type your variable is storing.
Yes?
Yeah, there are functions to change the data type. So for example, if you want to change x to a string, you can use the string function, string x.
Yeah, try it. Just control enter. Yeah, you can do that.
X.
You can change the or you can do int. So there are types, but you don't need to actually define. So you don't need to put like int x equals 4, or character or string y equals the hello. You don't need to do that, right? You can just define like this. So there's other functions. So str is string, int is integer, float will be decimals. You can if you want to, but not necessary. We won't be doing that. Okay, so delete all of that. Just leave the 4 and 12 up. Okay, so remember, our task was to ask the user, what is your age? Let them type something in, and it'll print, hello, you are like 12 or something. Yeah, something like that. So what we do is there's a function. So there's a function called input. Okay, so if you do this, age equals input. No, no, that's Python 2. So if you have Python 2's raw input, wait, I think I told you to install Python 3, so it should be okay. So just do like, what is your age? What is your age? Just do that. So what this does, it's going to ask the user, what is your age? So if you control enter, oh, they don't have, oh wait, this is Python 2. Oh, type raw input.
Okay.
Oh, this is Python 2.
It is raw input.
Oh no, but in Kaggle it's raw in, no, wait, what? Wait, it doesn't work on
Wait,
this?
this is 3.0, right?
It should be. Wait, control enter again. Wait, did it allow it? No, it's supposed to be.
It should be.
Give me a second. Okay, it doesn't matter about then. Okay, I didn't know Kaggle didn't support it.
This one and
Yeah, it doesn't support it. Okay, who cares? Delete that. That's unfortunate. It should work. Anyways, if you do that in Jupyter notebooks or other like PyCharm and stuff, it will work. It will ask the user for an input, type it in, and then you have to. So after that, okay, just do the controls there. So once you have that, so pretend that. So when you type a number in, I want to print like you are something age. So how are we going to do that? How are we going to print this variable? You are what? How are we going to print after that, like 12 or 12 or like 10? Does anyone have any suggestions about how we're going to print it? No, yes?
Just the number print age.
Okay, try it. Just write it. See, okay, this is to print. So no, not age.
it's not going to work.
So what you mean is you were saying so print and then apostrophes I am you are and then what are you going to do?
Alright, so you want to concatenate.
Yes, exactly. Concatenate at the end. What are we going to do? Plus?
Plus, yeah.
Yes. Use the plus. So you do plus and then age. Just write age. Right? Yeah.
I think
But
you can use comma as well.
yeah, you can use yeah. But there's an error. Okay? Because although Python doesn't have types, right? It does require you in some certain functions to define your types. So look at this. This is a string, right? This is not a number or some other thing. But this is a number. So how can you put a string and a number? You can't how do you add a string and a number together? You can't. So what you need to do is you need to change this into a str or a string. And so you saw last time, how do we change this into a string? We just append the function str. So you just do, so at the front, so it's a function. So you just write plus str age. So that's all you need to do. Once that happens, you converted this number, right, into a string. And now it will print. Okay,
This won't work unfortunately because
but it will work. Just on here, it doesn't work.
it won't work here.
That's sad, but don't worry, it's not important, but we just want to introduce you to some concepts. Okay, next. So to add new cells, yeah, it's a projector problem, I think.
Yeah, it should say.
Yeah, it's supposed to say 12. This is a projector problem. But yeah, see, this works if you just do that. Okay, anyways, next cell. So you can, oh wait, you have to press add. This is the add part. Yeah. So you just add cells. You can add cells and then they're executed differently. So the next things we're gonna learn include loops, right? So pretend I want to print 0 to 10, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Obviously, well, you can literally just do print 1, print 2, print 3, blah, 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 right? But that's very annoying. What happens if you want to print like 1 to 10 billion? Well, are you going to do that? Are you going to do print 1, print 2, print 3, blah, 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 print 10 billion? No, we're not going to do that. So in programming, what we can do is we use loops, right? If you're doing some other programming languages, they will normally teach you like while loops and for loops and stuff. So in Python, it's the same. So, we will just do for. It's the same. Just do for. So,
We use while.
I don't know, but that would be. Oh, fine. Yeah. So what you do?
Indentation. Yeah.
No, you have to put the thing.
But one more thing about Python which is really annoying, your indentation has to be correct. So basically the number of spaces you use.
Yeah. So what this code means? Okay, so in Python, when you apply like a loop or something, so if you say it in English, while count is less than 10, right? That makes sense. While count is less than 10, I want to print the count, right? I want to print the count. You have to put this. And when if you put it, it will automatically indent. So you don't need to you don't need to indent yourself, it will automatically indent. And what you want to do is you want to print the count. Now just do count equals count plus 1. But remember, I want to add 1 to it, right? So how do I add 1? I'm going to literally add 1, right? I'm going to reassign the variable and add 1. So once I add 1, so if it starts at 0, right? It will go to, 0, it will print 0, right? The next one, it will print 0 plus 1, which is 1. And so on, right? This is how it looks like.
Yeah, so basically what's happening is, so you've initialized your variable count and assigned 0 to it. So basically a variable is just something which represents the memory address of a value. So here we have the variable count and the value 0 is stored in this memory address. And here we have a while statement. So basically it checks if count is less than 10, then do this. So it will print 0 because that's the current value. And then it will increment count by 1. So count equals count plus 1. It's not a mathematical statement. 1 doesn't equal 0. It basically means that update the variable count and make its new value count plus 1. So count is currently 0. Now it will be 0 plus 1, which is 1. So effectively count is now equal to 1.
Yeah, so does anyone have any issues with that? Yeah? Oh, in Python? So in Python, we care about indentation. So if you want to write a new one, all you need to do is just enter, and then just delete this indent.
Oh, okay. So
that's all. Yeah, you don't need to,
Yeah, it's not like other languages where
yeah, you need to do it.
you need to
Yeah,
use
you don't need to do that. So maybe this is not very good style, but it will save you a lot of time. And that's the whole point. Python tries to save you time. So this is while. So does everyone understand this? Or anyone need me to re-explain or say it in a different way? So to say it again, it's just read it in English, right? While count is less than 10, print count. And then count, just add 1. That's what it actually says. Right? Python, when you read the code, it actually means what it says. So the next one is we're going to introduce you to for loops. Right? So enter, and then delete the indent. Or And just do it. Right, so there is another way to do this. And this is called a for loop. So if you write for, no. So what you do is you do for, wait, I'll just write.
Exit range.
Okay, so what this means, just say it in real English. For x, which is a random variable, right, in range 10, right, print x. What does it actually mean? It means range is getting from 0 to 10. And that's what it actually means. For every single number in the range from 0 to 10, just print it. So, what? Oh, did you do?
Yeah.
Oh, you forgot the thing. You deleted the.
Oh, really?
You must have that. Right, it should be 0, 1, 2, 3, 4, 5, 6, 7. Yeah? Do you get it? So just read it.
So this is from the while loop, and this is for the for loop. As you can see, the output's the same. If you want, I can remove it or comment it out, but this one is it.
Also, in for loops, you don't need to define a variable. You don't need to add 1 every single time. It doesn't add 1. It increments within the range. So no, yes, and any problems? Are you sure? So let me just ask a question. How many of you have not done programming ever? Okay, you can put your hands up because we might have to. Yes? No? Oh, never. Okay. Do you understand it? Are you sure?
Yeah.
100% sure?
Yeah.
Because if we don't understand this, will get very hard later on.
No, I get it.
Okay. So remember, when in Python, you just need to say it in English, right? So for x in range 10, right? Print the x. That's what it actually means. Not like some other languages, like there's some silly, stupid names, right? Python tries to make it readable to the human. Okay, so that's while and for loops. In my opinion, well, just use for loops. I never use while loops actually. But if you like while loops, use it. But for loops are it makes more sense. Okay, so now, pretend I want to print, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but I want to times it by 2. How do we do that? We just times by 2. So inside the print, just times by 2. Yeah, that's all. Wait, did you? Oh, no, yeah, do it again. It's slow. Right, see, you just times by 2. Or you can times by 3 or whatever you like. Alright, you can also do, so Python also understands BODMAS or BITMAS, whatever. Right, so if you do stuff, it will, if you do +1 at the end, divide by 2, whatever, it will print out all your stuff. Okay.
So go on to lists now.
Already. Okay.
You want to discuss something?
Oh, yeah, one more thing.
Statements.
So, no, not that. It's statements, yeah. Okay, delete the print thing. Just leave that. Okay, so let's use this loop. I want to make a program. Every single even number, I want to say hello, right? And every single odd number, I want to say bye, right? How do I do that? Well, in Python, in Python, no, remember, not the brackets. No brackets. Remember, no brackets in Python, okay? Not like C or some other languages. No brackets. So what we want is every single odd number, I want to print bye, and every single even number, I want to print hello. How are we going to do that? So, if you know this is called the modulus function, what a modulus function does is it gets the remainder. So, if I do x divided by 2, what's the remainder? If it's equal to 0, right, in Python, equals means if it equals to 0, right, not equals. If you type equals, it will assign a variable. We don't want that. We want to compare. So, if the remainder is equal to 0, what do we want to do? So just print hello. Okay? So, so this is even numbers. Okay? And what happens about odd numbers? So you can use, if you use C or something, it's called else if. In Python, it's called elif.
Yeah, elif, but in this case we only have 2 conditions, so we can just use else.
Oh, but you still just use elif. So what elif does is pretend if the first condition fails, what am I going to do next? What am I going to check next? And elif means else if. So if this is not satisfied, I go to the next one. So if it's not so if I divide by 2 and the remainder is not 0, so this is odd, right? I want to print, so just, print this number is odd. Yeah. And so if you execute it, right, even, odd, even, blah, 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 blah. Yeah? So you have to use, so this is your control, like this is your structure, right? If something equals to something, do something. If something equals to something, do something. And pretend if you pretend everything else. How do we write everything else? Like pretend we have some stupid case, like someone did like a float number, like a decimal number like 2.5. How do we, so, or you just, okay, this is not a good example, but what else means is everything else. So what happens if the first condition fails, the second condition fails, the third condition fails, what do? So we use else. Else means everything else, what are we going to do? Just print like error. Or, or not a number or whatever. Obviously there's no error here.
There won't be any.
There won't be any error. But you need to, else is useful. Okay, so this, remember this. Also, if you have Kaggle and stuff, it automatically saves, so you don't need to click like a save button or something. Okay, so,
If statements, yeah.
oh wait, we already did it. Oh, list now.
Oh, yeah, list.
Okay, new cell. Yeah, does everyone understand that? So if, else, if, else, else. Yeah? No? Okay. If you have problems, just, just say it out. No? Yes? Okay. So,
If I include something like 5.5, will that entire cost say million?
so if you put 5.5,
Yeah, will the entire cost say
wait. So if you put 5.5, so we want it to be odd or even, right? So what we did in our program was we said that if the remainder doesn't equal to 0, I just want to print it odd. So it's not right, right? So it will just print it's odd. 2.5 divided by 2, right? We'll have a remainder of 0.5, and then it will just print this is odd. Obviously, if you so what I think I know what you want it to print it's not, right? So you need to put another condition in front, which says that if it's a so Saksham, just put it change this equal to 1, equal 1. Then this is what you need to do. So if it's an integer, when you divide it by 2, right, and the remainder is always 1, then it will say it's odd. And everything else, like what you said, which is supposed like 2.5, it will just print that. So try again. No? Did you understand, or did I not understand you? Are you sure?
What was the question again?
I mean, when dealing with different data types that are like float and integer, if I include something like pi or 5.5 or whatever, so will the integer cost be boolean or
Oh, true false.
Alright, yeah.
Oh, sorry. No.
I understand, yeah.
I didn't? So you mean if, oh no, it won't do that.
And then we'll just move on to the else, we'll print NaN. If you have a floating point, so like 4.5, obviously you can't return remainders with decimals, then it will just print NaN.
Okay, so, yeah? Any other questions? So last topic we're going to introduce is lists for today. Okay, so what is a list? So a list is literally a list, right? It's just a list of numbers. In maths, probably an array or matrix or whatever. So why are lists important? What you can do is you can put whatever things you like. So just change the 5 to like a character like hello. Or something else, like do something silly. Complex numbers, let's put a complex number inside. 7 plus 10j. In complex numbers, it's j.
Is it capital
It's
or
small j.
or-
That should work.
In Python 2 it's capital J.
Oh, just a capital J. Okay, so that's a complex number. I is j.
So yeah, this is the imaginary unit, and J is the imaginary unit, this is the imaginary part, and real part, 7.
Yeah, okay, so you can put whatever you like inside here in a list, right? And why do we need to use lists? Well, a list makes your job easier. Pretend I want to print every single one, right? I want to print 2, 3, high, complex number, and 11. So what are we going to do? So go to a, so just control enter. Oh no, control, no, wait, what happened to that? So a list, remember, has a list has square brackets, okay? And you separate elements by commas, okay? And so pretend I want to print every single one. So what are we going to do? Can anyone give me suggestions? How are we going to print every single element inside? Using the things that we learned before.
For X ins.
Yeah, good. 4 in English, 4x in primes. And then print x, exactly. Print x. It works, see? That's what we need to do. We want to print these things inside, just say it in English. 4x in primes. For every single thing inside this, print the x. That's what we need to do.
If you want to print individually, then you can print primes and choose the index. So Python index always starts at 0, as with most languages. So this is the 0th element, the first element, third element, second, third, fourth. So if I wanted to print the complex number 7 plus 30j, it would be 0, 1, 2, and 3. So we print 7 plus 30j.
Yeah, so in Python, yeah, so the list, so the area, so like this is the location. So this is 0, 1, 2, 3, 4. And using this, using another square bracket, we can call the element. So pretend I wanted to print the last one. So what do we do with the last one? We just put -1. Oh. Wait, what? What do you do? No. So you just, so yeah, print -1 is the last element. So in Python, negatives go backwards of the list. And the second last element will be -2 and so on. -3, -4, -5, and forward would be just 0, 1, 2, 3. Okay? Wait, what?
Just a quick tuple. So basically a tuple is similar to a list, except we use these parentheses to represent it. Basically the main difference is that a tuple is fixed, like it's read-only. You can't add any more or change any information inside the tuple. So for example, if I wanted to remove this element, I could remove using del, I think. Del set1 and whichever element. But the thing with tuple is you can't what?
No, I mean, we didn't explain what tuple is.
Okay, a tuple is basically a list, except you can't change any elements inside it. So I can't add any more elements or remove any elements.
Yeah. Wait, I was just. Okay, so a tuple we'll discuss next week. But anyways, there's one more thing. So you can do something like this. I'll show you. You can do some silly stuff in Python, and it's extremely useful. Your box under. Okay, so in list, right? Remember square brackets. So this is what I can do. Right. So what does this mean? It means so instead of so this is how we can get like 0 to 10 using just a list. Right. So what this means is 4x in range 10, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I just want to put x inside the list. And this is what you need to do. X, 4x in range 10. So, and then this is your output. Your list has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this will be extremely useful in your later, if you use Python, this will be extremely useful.
It's more convenient basically rather than
don't worry about the append stuff.
Yeah.
Yeah.
Why? How does it know what x is? Like, could you say y to y in range? Like, is x a default variable?
Oh, you don't need to. You can use whatever you like.
Oh.
So try y. Yeah, you can do whatever. But it has to be the same. Yeah. No. Control enter again. Control enter. Yeah, it will go. Yeah. So you can choose whatever name you like. Yeah, that's all for today. Thank you for coming.